Hey everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be starting chapter number 9. I got good news and maybe bad news. If you like chapter 8, if you like the chapter on trigonometry, good news for you today. Chapter 9 is more trigonometry. If you did not like the chapter on trigonometry, I've got bad news for you today. Chapter 9 is the same as Chapter 8. It's about trigonometry. So depending on what you thought about Chapter number 8, that will probably tell you a whole lot about whether or not you're going to like Chapter number 9. I will tell you that I think that now once you have a little bit of a base on trigonometry, I think Chapter number 9 might come a little bit easier for you because you already kind of maybe get it just a little bit. So we'll see. Let's jump into it and see what happens. 9.1 is on page 416. And on page 416, it talks about the special angle triangles. There are two special triangles. Now, remember, they're all right triangles. Every triangle we're working with right now is a right triangle. But there are two triangles that are what's called special triangles. You see these special triangles all over the place. You don't know that you're looking at them, but engineers use them, designers use them, architects use them. I'm just telling you, they're everywhere you look. Now, once you know what they are, you'll start looking and you'll start seeing them in different places. But the two special case triangles are 45, 45, 90. That one's on page 416, and the next one on the next page is the 30, 60, 90. What do I mean by that? Those are the degrees. I'm saying the degrees. So let's look at this first one, the special case of the 45, 45, 90. Take a look down here. So in a 45, 45, 90, here's what happens. Because these angles are equal, it does something. It makes these sides or these legs also equal. So let's just call it, we'll just throw a random number out there. Let's say this is 5, then this is 5. Has to be, okay? Because it's a 45, 45. This is like, because these are equal, these things cannot change. They have to be equal. No matter how big or small you make the triangle, it's always going to keep those two legs equal because those angles are equal. So let's call those sides, instead of calling them a number, let's call them a variable. Let's call them x. So x and x, they're always going to be equal. They're always going to be the same. So it doesn't matter which one you put where. You call one x and one y, that's fine. You would have to say somewhere that x equals y, because they do, because it will always equal. You call them a and b, that's fine, but there's still going to be a. A is always going to equal b in this case. So if you call them a and b to work the Pythagorean theorem, it's fine, it's okay. But it's always going to be that a equals b. They're always going to be the same when this is 45 and this is 45. Okay, now we have two legs, but we also have a third side, and that's the hypotenuse. So what is the hypotenuse in this case? Well, we don't know yet. How could we find the hypotenuse? Well, one way to find the hypotenuse is always with the Pythagorean theorem. A squared plus b squared equals c squared. Now, instead of values for a and b, let's just use these x's right here because, remember, I said it always equals. So we could put x squared plus x squared equals c squared. What do we do here? We combine those because those are like terms. 2x squared equals c squared. How are we going to get that by itself? Well, remember, we're trying to find out what c squared is. So how can we do that? Well, we can square root this, right? Okay. So what happens when we square root that? Well, the c comes out, and what else comes out? Look, the x comes out. So the x comes outside, and the 2 stays inside. The solution to the hypotenuse is x square roots of 2. X square roots of 2. Okay? And we use Pythagorean theorem to prove that. Now, no matter what you put in for x, let's say we put 5 in for x, and that's a 5, then this is going to equal 5 square roots of 2. It's that easy. You just plug it in there, and that's what it equals. I like special cases. Some of you are thinking, yeah, I know, right? They're great because they always equal the same thing. And so you just plug in x in all, plug in whatever your x is in all the different places, and that's your answer. The 45, 45, 90 is very easy to work with. What do you need to memorize about this? Well, there's a few things. Let me kind of work my way around this. First of all, you need to memorize that the legs always equal x. Legs equal x. Legs are always the same, that legs always equal each other. Okay? The other thing that you need to just memorize is that x square root of 2 is the hypotenuse in a 45, 45, 90. Just memorize that. If you look at the chart, look at page 416, you're going to see a chart. It's right there. But memorize the chart. Don't always have to go back and look at the chart, because you're going to get into some positions where you're on a test or something where you don't have the chart available to you. Once we get to trigonometry, you're not going to want to go back to that chart all the time. Just memorize it. It will save you lots and lots of time, okay? And then you can find anything that you want. You can plug anything that you want in for that. Now, let's do one. And what I'm going to do here is I'm going to substitute some things in. So let me kind of erase some of this stuff over here. And what I want to do is I want to just substitute in. So in other words, I want to put x equals something. So let's say that x equals 3. I'll just use a random thing. So what are the legs? So if x equals 3, well, that equals 3 and that equals 3. What's the hypotenuse? 3 square roots of 2. Done. That easy. Okay. All right. Now, what if I know that the hypotenuse equals 4? Hypotenuse equals 4. Well, wait a second. This is a trick, right? I thought you said that it had to equal something square root of 2. No, I didn't. I said that it will always be x square roots of 2, but we don't know what x is in this case. We know what the hypotenuse is in this case. So how are we going to figure it out if we know the hypotenuse? So if we know that hypotenuse equals x square root of 2, and we know that it equals 4, okay, how can we solve for x? Well, just solve for x. Oops, sorry. In this case, we're just going to solve for x. How do we do that? Well, what do? You divide both sides by the square root of 2. That's going to cancel that, and I'm going to get x equals 4 over the square root of 2. Now, the problem is that is not a good answer in algebra. What's wrong with that answer? That's right. We have a radical in the denominator, and we can't have that because that is irrational denominator. So we have to multiply both of these by the square root of 2, and that's going to cancel the square root, and so we're going to get, well, I say it's going to cancel. Let me do it so you see it. 4 times the square root of 2 is 4 square roots of 2. Square root of 2 times square root of 2 is the square root of 4. What comes out of the square root of 4 is 2. So it's going to equal 4 square roots of 2 over 2. Now we can cancel that, right? So we can reduce that. So that comes out to 1, that comes out to 2. So our answer is 2 square roots of 2. X equals, or each leg equals 2 square roots of 2. 2 square roots of 2. And in this case, this would equal, what did I say? It was 4. This one is 4. Okay? And that's how you work that. Just work your little formula. It's really easy when they give you the legs. It's a little bit more challenging when they give you the hypotenuse. But what do you do when they give you the hypotenuse? You do this right here. You do hypotenuse. What is the hypotenuse? X squared of 2. You do that equals whatever they give you. Let's say they give you 12. That equals 12. Let's say they give you, okay, it equals square root of 3. Well, that's fine. Just make it square root of 3. And then what you do is you just solve by dividing both sides by the square root of 2, and then you rationalize your denominator, and you're good to go. Okay? So that is special cases with 45, 45, 90s. All right, now let's focus on the 30, 60, 90 triangle. It is basically a half of an equilateral triangle. So if I take my equilateral triangle and then just cut it in half, it makes a 30, 60, 90. So it's also a special triangle. We use it all the time. We see it all the time. It's used a lot in trigonometry. So just get used to it, and you need to memorize some things about it, okay? What are some things that we need to memorize? Well, if you will look at page 418, you will see the little chart there on the top of page 418. So there's a long leg and a short leg, okay? So if you look at this one here would be the long leg, LL. And this one down here is the shorter one, so this is the SL. Long leg and short leg. Now, also, obviously, it would have a hypotenuse, okay? So these are the three kind of the pieces of the 30, 60, 90 triangle. When you're doing this, you just need to memorize what these pieces are. Now, you could go through it, and I could show you, like I did with Pythagorean Theorem, how you get it, but I'm not going to take the time to do it. Let's just memorize these pieces here. Okay, so the long leg is going to be x square root of 3. The short leg is going to be our x. And the hypotenuse is going to be 2x. All right, so you would just go through and you just work the system just like you did. And these are all like little formulas. You just kind of plug them into the formulas. So let's say that they tell you that the short leg equals 12. This is the example on page 418. So short leg equals 12, okay? And they want you to find the other ones. So if the short leg equals 12, so let's do short leg equals 12. In other words, x equals 12, because the short leg is our x. This is the easiest one. So we'll start with that one. So now let me do short leg equals x, long leg equals x square root of 3. So in this case, what is it going to equal? And then the hypotenuse. So here's what we want to do here. All we're going to do on this one is just plug it in right there. And so that is going to equal 12 square roots of 3. And then with the hypotenuse, it equals 2x. And again, we're just going to plug it in to where it goes. And so that would equal 2 times 12 because we're plugging in. And so that would be 2 times 12, which would then equal 24. So there's our 3 pieces to that one. So it would be hypotenuse is 24, and the long leg would be 12 square roots of 3. Okay, well, how do we do this if we have something different other than the short leg? The short leg's the easiest one because that's the x. But we can still do it with the other pieces. So let's say that we know that the hypotenuse, if you look at the B one, on this one they give us the hypotenuse is 12 this time. So now they say, okay, now the hypotenuse equals 12. And so here we would say, okay, the hypotenuse equals 12. So 2x equals 12. So how do we solve for x? It's easiest always to solve for x. That way you can plug it back into the other one. So we would divide both sides by 2, and we would get that x equals 6. So in this case, x equals 6. Okay, hypotenuse is 12. Cut it in half. That's the short leg. How do we get the long leg? Now we would just put that in for x, and we would get 6 square roots of 3. Okay. Now we'll do the one that's just a little bit harder. I say it's a little bit harder, and it's not really that much harder at all. So now we are going to say that the long leg, all right? So now we're over here, and the long leg now equals 12. So now this one equals 12. It's just a little bit harder, but what we want to do is we want to get x by itself, so we want to divide by square root of 3. Divide by square root of 3. Well, we can't leave it like that because we have to rationalize the denominator. So when we do that, we get 12 square root of 3 over square root of 3 times square root of 3 equals square root of 9. Solve that out is 3. Now we can reduce that to 1 and 4. So there it is. 4 square roots of 3 is our answer. Okay, so 4 square roots of 3. So that's x. 4 square roots of 3. And this is 12. Okay. Now what we would do is we would plug this into the hypotenuse. And so we would get 2 times 4 square roots of 3, or just 2 times 4 is 8 square roots of 3 would be our answer for our hypotenuse. 8 square roots of 3. Okay? So there's your answers for all of those. I went through those fairly fast because I feel like you know the algebra behind that, how to do radicals. You know how to solve these things. So I'm not going to take a ton of time showing you how to solve it. If you don't, you need to go back and watch the videos on how to solve radicals. Now, what's another thing that maybe you would have to do at some point? You might have to square factor out your radicals. So be watching for that. But that's the short of how to do the 30, 60, 90 and the 45, 45, 90 special triangles. All right, that's all I got for you. Hope you have a good one. Bye-bye.